Okay. So my name is Stefan. I'm working for currently for Intel as a contractor in France, and we are working on the Tizen project, and I'm the release engineer for Tizen Common. Okay. And my talk today is about creating an IoT device. And just for the fun, I choose to try to to use Tizen to make it. And I saw that it was quite easy to achieve some things, some funny things. And I will try to show you some recipes and some how we can do some IoT stuff with Tizen. So the agenda is a demo, roughly on 10 minutes. Then I'll try to show you what I did with Tizen to what I changed to achieve the demo, and then we'll get the question and answers. So what happens? I have two minor boards here. Okay, two minor board max. This one and this other one. This one is plugged on a gyroscope, accelerometer and magnetometer here in my little car. Okay, so we suppose that the car is transporting a crocodile from one zoo to another. So it's very dangerous. We shouldn't, the crocodile shouldn't escape, and the car shouldn't crash. Okay, so we'll try to monitor what happens on this car. So regularly, we'll get some information from the accelerometer and get the behavior of the car. Then we'll push the data regularly, but only when we get some events. So this first board is quite intelligent in the fact that we sample things very quickly, something like 100 Hertz or something like that. But we keep, and we make some calculations, and we keep only the events that make sense. And then we'd forward the events to another one, another board, I mean, through a Bluetooth connection. This other board will display the behavior of the car, and will also, I just simulated some kind of cloud somewhere, which is in fact on my laptop. So I try to switch, if I can. Wow, fantastic. So as you see, I have a little Node.js server on my laptop, and I'm refreshing this page regularly. I could have done WebSockets, but I was in a hurry, so I was lazy. I'm just refreshing every 2 seconds. And then when I change the orientation of the car, I should see that we get some warnings or some alert. And if I let the car like this, I get the crashes. Okay, so to display on the screen, I don't know if everyone see the screen here. So you have the screen connected to the second board, where the car will also be, the behavior of the car will be shown. It works or not? Yeah, it works. So depending on the angle, on the X or Y angle, it will show some kind of warnings. Okay, so you could imagine anything. In fact, it's just for the demo. So back on the. Like to put. Okay. So how did I make that? I just took a Tizen Common release, the latest one. I mean, the one I released this week. I modified some things to for the Bluetooth, and because we don't have any display, I mean HDMI display or VGA display, we don't need any Western or XOR server. So I removed the display servers. Also, we don't need any UI API or graphic API of some kind, so I just remove them also, at least for the board that makes the acquisition. For the other one, I kept some graphic toolkit because I just wanted to display something on the frame buffer, but that's all. So for the communication, I mean for the Bluetooth communication, I didn't have time to integrate the latest libraries that are coming. I mean, IoTVTs was announced a few weeks ago. I mean, the first release was released last week or something like that, or 2 weeks ago. I didn't have time to integrate that, but the idea would be that the two boards should recognize themselves seamlessly, and the other one should be able to send this data to the internet securely, and etc. But I didn't use this abstraction layer to make things work on this demo. I just use a RIFCOM communication bit for the Bluetooth. It's quite simple. It works. I could have used some authentication or security above this layer, but it's just a demo. So why choosing Tizen for an IoT device? And what IoT device could we use? I think that, from my experience, we can't use Tizen on anything. I mean, we just need some memory and CPU power. For me, the minimum is 128 megabytes, and honestly, 512 megabytes is comfortable, and more often. For the CPU, a single core running at a small speed like 500 megahertz is enough. Could be less. I didn't make any test on that, but I'm quite sure that it works at 500 megahertz. For the display, we can run without any GPU, of course. For example, here I have a GPU in fact on my motherboard, but I don't use it. I just use a frame buffer because it's a USB device. The little display is a USB device. Okay. One point is that connectivity is required because we are in IoT room, so it doesn't make sense to be connected. So we can have Ethernet or Wi-Fi or Bluetooth and any upcoming way of connecting things. From what I tested with a wattmeter, the power consumption I observed on that board, for example, the Minoboard Max with a dual-core CPU with 1 gigabyte of RAM, I think, if I remember correctly. It's around 10 watts. Okay. I also tested Tizen on the Intel Edison board, the small board. We are roughly around 1 watt, or depends if you enable a radio, if you do Bluetooth, low energy or not, etc. But that gives the range. So the typical hardware on which we can make Tizen run, I mean where we support Tizen officially, some Minoboard Max, some Intel NUCs based on quite the same CPU as a Minoboard. The Intel Edison that was launched in October 14. Some ARM boards also, like the Odroid and other generic boards. So as you see, we are quite large for the hardware we can support. So anyone can find the board that fits the most the project. I mean, if you want something very integrated, you can take or you have a lot of things to plug. You could use a Minoboard. If you want just a small computer, you can take a NUC, etc. etc. If you have a small project you want to develop and sell, probably the Edison is the best way to achieve things. So everyone is able to choose the best board. Why choosing Tizen? Tizen is claimed for the OS for everything. It was the first baseline of this OS, but honestly, I think it's not very true. But you can install Tizen on multiple platforms and a wide range of hardware. So you can, with the architecture, you can dedicate, you can cut the APIs, you can adjust things the way you want. For example, Tizen command is just a base for constructing a profile, for building another profile dedicated to a given task, for example, for a TV, for a smartphone, for anything. And IoT devices are just a range of new profiles for Tizen. So it's the same philosophy that the previous one that was developed in the past years. So we have a lot of lot of components inside Tizen. I mean, we offer a lot of components. Everyone can use them or not. It's clean, quite comprehensive. And one point which is important for me is that Tizen is a new Linux distro. It's not just based on Linux, as you may know some operating systems that are based on Tizen. Tizen is a real GNU Linux distro. Yeah, it's very important because you can take some piece of software coming from anywhere and you just recompile and run that. You don't have to use a new SDK, use new things, etc. No, if you want to run a native application on Tizen, it's very easy. It's like running on Red Hat or OpenSUSE or anything. So it's an important point for integrating new software coming from outside. If you want to make it run on Tizen, it's possible. So the main features are that Tizen is a connected distribution. I already said that we need some Ethernet or Wi-Fi, etc. It's secure. It's a, I think, very interesting point for IoT things. So the platform is secured with SMAC, and of course, when we we will extend things with other devices or on the internet, we will probably use frameworks that propose security, like IoTVT, but any other framework with security would fit. So it's suitable for embedded platforms. Recently, we released the Yocto version of Tizen. So you can build, right now, the build is made with two systems. One with the OBS, which is the historical system, the legacy system for building Tizen, and a new one, which is the same but based on Yocto recipes and bitbake. So everyone will have the choice, either to choose the OBS version, it's more like an OpenSUSE distro or something like that, or simply a more embedded distribution like Yocto. And lastly, Tizen will be more IoT aware. I mean that we are currently integrating the IoT development kits. I will give some details after. And also IoTVT layers. So I made some adjustment, as I said, for the kernel, for example. For the minor board, I didn't have to change anything on the kernel because it was a supported platform. But for example, if you want to run Tizen on Edison, you would have probably to patch the Tizen kernel with Edison-specific patches. So anyway, it's a usual hardware abstraction layer you have to adjust depending on your hardware. Also, the minor board in my demo are headless, so I just removed the graphic and UI components, like the toolkits and the display servers, etc. I also removed the web apps functionality, which is a best functionality of Tizen for many people. But in our case, I didn't want to make some web apps run on the minor board, so it didn't make sense. I just coded the most of middleware with Node.js. It's easy and it's yeah, it's easy to set up and it works very well. Some new Tizen API were introduced recently, I mean in the last year. And I think that would be very useful for the IoT world. The wearable API was introduced with a specific calls for wearable things. I mean, on something you wear on you, for example, a watch or comment on dit ceinture? A belt, yeah. A belt. I saw that. Comment dire ça tout? Yeah, you have intelligent belts, so that's some kind of wearable API.
Batman means? Batman or special bear where you can
There was also some device management APIs that were introduced, some sensors APIs, and the IoT specific APIs that are currently introduced. That's the usual architecture of Tizen. So I just mark what I removed. As you see, we can keep some interesting things. For example, in native APIs here, we can keep the social and content API. So we are able to develop some native Tizen applications and make them run on the IoT devices. And we are able to use all of those APIs instead of trying to reinvent the wheel and etc. Of course, depending on your project, you will probably remove the APIs you don't want, but we can let them where they are. It doesn't matter. And it's the same on the core application layer. We will remove the non-supported things depending on the hardware or on the project. And probably the kernel and the security stuff will stay the same. The way to customize is, I would say, as usual. We have the Tizen.org reference APIs and all the architecture I showed just before. And you can just make a copy, a kind of copy, or you could have the same layers on your site. And depending on the build system, you'll have to glue the way that both layers can merge, and you'll get some specific private version of your Tizen. The idea is simply to integrate your specific hardware, for example, your kernel, your bootloader, depending on your platform, etc. If you have a specific API for something, just put it here, or perhaps here, I don't know.
Stefan, you have 5 minutes, so we can go to questions now.
Yeah. Okay. So I just talked about IoT. There is a presentation by Brendan Leffel. It's at 12, I think. And it's about the IoT dev kit. Very interesting. I could have used it for, didn't. There is a LED blinking each time some data is sent between the boards. And you don't see it, but it's blinking. I could have used those two libraries to just make the link blink, the LED blink. And also I could have used the UPM library to get the data from the accelerometer. But it was too late for me. And IoTVT, there will be today another presentation about that, I think, Philippe?
On the last hour, there is an open hour for showing demos, and I can show you how to use IoTVT on Tizen. So let's do it.
Okay. So if you have questions? Yeah. Any questions?
Which ARM platforms do you run on?
We have the Android officially. Yeah. The question was, what are the ARM platforms supported on Tizen? We have the Deviot03, which is supported. I think that Samsung will also support some Arch64, I mean ARM 64 bits architecture. I don't know the boards, but they have some. This architecture is also supported. It's a Gear 2 from Samsung. And we have some Versatile Express profile, which is supported from the kernel. For example, we tested the Tizen on Olimex boards based on Allwinner A20 CPUs, for example. I'm sure that it could work on the other boards. I would say that the main problem on ARM boards currently is the GPU driver. But if you make some IoT stuff where you don't need GPU drivers, you're okay. So Raspberry Pi is a good target for that, for Tizen. Another question?
So you removed some parts of Tizen to the application. Is there a configuration tool to remove this, or did you manually?
No, I just, at the moment when I created I should repeat this question, sorry. The question was, how did I remove some components on Tizen to make the demo? It was very easy because when you first build all the packages in Tizen, we have something like 800 source packages which leads to 2,000 binary packages, and then we assemble those packages in binary images, and we say we want that, and that. So when you assemble, you can say no, I don't take that, and using the usual dependencies workflow, you'll get just a small image, IoT image, I could say, of Tizen. Okay, any other question?
Okay. Well, thank you very much, Stefan.
You're welcome.